Okay, the following is a video, the second video on how to graph a derivative function. So I'm going to come over here and I'm going to create a square grid, x and y coordinates, and then I'm going to plot a function. I'm going to plot the function f of x is equal to x cubed, so a cubic function. And I'm going to come over here and I'm going to create a tangent line. Well, as close to a tangent line as I can. It's really a secant line, but for our purposes, this will do a good job of modeling what we need to do. So if I come here and I take this x value here, I'm going to go ahead and measure what that x value is, where that is along the x-axis. And then I'm actually going to measure the slope of the tangent line. Okay. Now, I've got those two things here, and you see them over here. So I have my x value and the slope value. I'm going to animate this line, and I want you to see what happens as we animate that line. The slope changes. Okay, as we as x goes this way, if we move the tangent line this way along that function, the slope changes. I'm going to start over here, and I'm going to stop it right about there. I'm going to keep going just a little bit. All right. So if I take the x value of point A, and if I take the slope of that tangent line, and if I were to actually plot that point on the graph here, I get this other point here. All right, now I'm going to label this point, I'm going to measure the x value on that point, and then I'm going to measure the y value on point C. And the interesting thing about point C is that the x, if we compare point C to what's happening over here on our function, point C is generated by the same x value. Notice how x sub A and x sub C are the same thing. But the y value on point C is generated by the slope of the tangent line. Okay, now as I move point A, or move the tangent line, point C changes. Point C kind of moves down and then it moves up as the slope of the tangent line moves along the function. Now what I'm going to do is I'm actually going to plot or trace point C to see what kind of function point C is going to give me. So if I select point C and I show, if I trace that plotted point, I'm going to come here and select my line again, and I'm going to animate the line. But I want you to see what we get as a result. And it's kind of interesting, but given a cubic function, if I take the derivative of a cubic function, it's actually going to give me a parabola. So if I were to plot a point from my derivative, and my derivative generates the slope of the tangent line at any x value, and we collect all those points and put them together, we're actually going to get a parabola. So it's a pretty interesting thing here. Now, if we know from our rules that f of x is equal to x cubed. If I were to take the derivative of that, it's actually going to give us 3x squared. So if I come in here and I graph 3x squared, then it actually lines up and matches what we traced from point C, which is pretty unique. Okay, so I want you to see that this is our function, and if we take the slope of the tangent line of the function and plot that as the y value, then we actually get a derivative function. And so I want you to see that that's what's happening here. This is some pretty cool stuff. Hopefully this visualization is helpful. Thank you.